A compound inequality is going to be connected by either an and or an or. Here's an example of a compound inequality. This one says that 3x minus 8 is less than or equal to 10, and 3x minus 8 is greater than or equal to negative 2. One way that we can handle this is to separate the inequality and to solve each inequality separately, as you see in front of you. We might also have inequalities separated by an or. In that case, the work is essentially the same. We would solve each inequality and write the appropriate solution. Let's work this one out together. Keep in mind though that when you're multiplying or dividing by a negative, that reverses the inequality, and we'll talk about why a bit more in class, but maybe you can come up with the reason why ahead of time so we can have some fruitful discussions about it in class. But in any case, we could separate this as negative 1 minus 2x is greater than negative 3, and negative 1 minus 2x is less than or equal to 5. We would have to add 1 to both sides of our inequality in either case to eliminate the constant. Over here we have negative 2 is less than negative 2x. Over here we have negative 2x is less than or equal to 6. We divide both sides of our inequality by negative 2. Remember, dividing by negative switches the inequality around. So now we end up with, on this side, x is greater than or equal to negative 3. And on the other side, we have 1 here. So x is less than 1. And we can write this again. We can unite everything since it's an and by saying that our solution is x is both greater than or equal to a negative 3, and it's also less than 1. Or if you felt like writing it, well, this is probably the more appropriate way, but there are other ways to write this as well. Try this out. Which one of these inequalities means the same thing as x is less than 4 and x is at least negative 9? So x is less than 4 looks like that. The fact that it says here x is at least negative 9 could mean that it's negative 9 or greater. So x could be greater than negative 9, or it could be equal to negative 9. So which one of these means the same thing? Definitely not these two. So it's actually D. So x is greater than or equal to negative 9 but less than 4. Which one of these answer choices represents the solution to this inequality? We know that if we separated it, we would have to add 6 to 8 and 6 to 6. So we would end up with 12 instead of 6 and 14 instead of 8. So that means that our solution is actually B. Which one of these answer choices represents the solution to what we have here? Well, if we were to solve each of these individually, 3x plus 8 is greater than 17, we'd have to subtract 8 from both sides of our equation, and we end up with 3x is greater than 9. Divide both sides by 3, and x is greater than 3. So x is greater than 3, and then for the other part, we have 2x plus 5 is less than or equal to 7. Subtract 5 from both sides of our inequality. We end up with 2x is less than or equal to 2. Divide both sides of our inequality by 2, and x is less than or equal to 1. So what we need is something that says that x is less than or equal to 1, or x is greater than 3. And A says exactly that. Try to see if you could solve this inequality. So we're going to actually show two ways that we can do this. One way is that we could separate it into two inequalities. So we have negative 13 is less than or equal to 5 minus 2x is one equality, and the other is 5 minus 2x is less than 9. We could start it off by eliminating the constant first. We always want to try and eliminate the constant if we have this kind of situation. And we have negative 18 is less than or equal to negative 2x on the left, and on the right we have negative 2x is strictly less than 4. Divide both sides of our inequality by negative 2. In either case, that's going to change our inequality sign. Remember, anytime we're multiplying or dividing by negative 1, do not forget to write the inequality sign the opposite way. So now we have greater than or equal to instead. And so this is going to be 9 on that side, positive 9, and x on that side. On the right, x is going to be greater than, this time, negative 2. So there's our solution. X is both greater than negative 2 and also less than 9. And we could write that as x is less than or equal to 9 or greater than negative 2. So we could have done it separately, but here's another way we could have done the same problem. Instead of separating it, we could have done the work all in the same problem. So we know we would have subtracted 5 first to all parts of our inequality. This would be negative 18 here. This would be negative 2x in the center, and this would be 4 here. We're dividing all parts by negative 2. And if you compare the other work, we did exactly the same steps. Negative is going to change the inequality. Dividing by negative is going to change the inequality sign, so we might as well change that and write whatever is going to be left over. So the division in the middle gives us x, positive x. Division on the right gives us a negative 2, and division on the left gives us a positive 9, which is equivalent to what we had before. We could also have written it this way, with the 9 here and the 2 here. It says exactly the same thing.